Hi, this time we're going to talk about limits at infinity. Finding limits at infinity is just actually asking the behavior of the function when the x's are too large positively or too large negatively, and most especially whether the values of that function approaches a certain number. So let's get started. Right. So before we begin taking limits at infinity, I just like to give some preliminaries before we actually take them. All right. So we have, say for example, you have a number c, and we divide that by a very large positive number. Let's denote that with the infinity symbol. This should give you a number that is very close to zero. Why? Because you are dividing a finite number with a very large positive number. For example, 5 divided by 1 billion. This should give you 5 times 10 to the negative 9. Or that means 9 zeros leading 5. But that's practically very small. We can actually say, well, it's just 0, sir. And the same thing happens when you have a number c divided by a very large negative number, still the same. This should be approximately 0. Say, for example, you have 7. You divide that by negative 1 billion. Again, you're going to get 7 times 10 to the negative 9, or you have 9 zeros leading 7, and practically that is 0. This is what we will keep in mind when finding limits at infinity. Now, to begin our discussion, we have here the problem. Find the limit of 3x minus 2 over 2x plus 1 when x approaches infinity. As is, we cannot do a substitution because we do not know what this infinity is. We just know it is a very large number, but we cannot do any analysis right now. If we will force it, you will get 3 times a very large number minus 2 divided by 2 times a very large number plus 1. That gives you a very large number divided by a very large number, which is senseless, absurd. Right. So if we can't do that, what can we do? All right. So this is what we're going to do now. Okay. So typical of finding limits at infinity is this. First asking what is the highest exponent with respect to x. In this case, the highest exponent with respect to x is 1, or that's x. And what do you do with that information? We are going to multiply this with 1 over x divided by 1 over x. Notice that this factor is just 1. This factor here is just 1. So multiplying this factor to the function does not change it in any way. Your function is preserved, but look at what happens. The moment you do that and you do the distribution, you will get the limit of 3x over x minus 2 over x divided by 2x over x plus 1 over x as x approaches infinity. Going further, okay, and canceling the x's, you will get the limit of 3 minus 2 over x divided by 2 plus 1 over x as x approaches infinity. Using the preliminary that we have, okay, I hope you still remember, dividing 2 by a very large number gives you practically 0. Dividing 1 by a very large number likewise gives you a number that's practically 0. That being said, therefore, the limit is simply 3/2. And there you go. All right. So I hope you got that, but if you haven't, don't worry, we have 4 more examples to go. Let's go to the second example. The second example looks like the first, except that there is no full expansion. Okay, so you will notice here that you have a binomial that is still to be squared and another binomial in the denominator that is still to be squared and another binomial factor. So, as is, it's not easy for us to ask the question, what is the exponent, the largest exponent with respect to x? Because we do not know, because the function is not fully expanded. So we have to first fully expand the numerator and the denominator before we can do our analysis. And how do we do that? So just go through it. The limit as x approaches infinity of, and then we expand the numerator. The numerator is easy. So that's 4x to the fourth plus 4x squared plus 1 divided by the denominator will have x squared minus 2x plus 1 times x squared plus x. You will see that at this stage, the numerator is already fully expanded, but the denominator needs another expansion. So we just continue. Be patient, right? So we copy the numerator, 4x to the fourth plus 4x squared plus 1 divided by, and then we do the expansion. This is x to the fourth minus x cubed. Where do we get the minus x cubed? Well, that's x squared times x, that's positive x cubed, and negative 2x times x squared, that's negative 2x cubed. So positive x cubed minus 2x cubed gives you negative x cubed. And then next we have negative 2x times x, that's negative 2x squared, plus 1 times x squared, that's x squared. So negative 2x squared plus x squared gives you negative x squared. And the final term, we have 1 times x. As x approaches infinity. Now it's easy for us to ask the same question. So, sir, what is the largest exponent with respect to x? It appears that it's x to the fourth. So because of that, we are going to multiply this with 1 divided by x to the fourth divided by 1 over x to the fourth. Again, remember that this is harmless. This factor is harmless, quote and unquote, because this is, after all, equal to 1. So your function is preserved, but this has a purpose. Okay, so if we continue taking the limit, this is now the limit of 4x to the fourth divided by x to the fourth plus 4x squared divided by x to the fourth plus 1 over x to the fourth. divided by x to the fourth over x to the fourth minus x cubed over x to the fourth minus x squared over x to the fourth plus x over x to the fourth. As x approaches infinity. Simplifying this will give us the limit of 4 plus 4 over x squared plus 1 over x to the fourth divided by 1 minus 1 over x minus 1 over x squared plus 1 over x cubed as x approaches infinity. Using the preliminary that we had, we know that a very large number squared is still a very large number, and so dividing 4 by that very large number is 0. A very large number to the fourth power is still a very large number. Dividing 1 with that fourth power of a very large number is practically 0 still. And likewise, and likewise. So finally, we get the limit of the original function is just 4. As x approaches infinity. Okay, let's take a look at a more challenging question. Sir, what if we have a square root? No need to worry. Okay? Don't be distracted by this. So all we have to find out is, sir, what is the largest exponent with respect to x? Well, it is x, right? Eh, paano yan, sir? There's an x squared here. Yes, it's x squared, but then if you take the square root of x squared, still it is x. So, sir, what do I do? Okay, so this is what you do because you have a radical. The limit of the square root of x plus 3x squared times 1 over the square root of x squared. Remember that the square root of x squared is still x. Okay, and then divided by 4x minus 1. In the numerator, it suffices we say 1 over x as x approaches infinity. Question, sir, is this still equal to 1? Because they do not look like the same. Okay, when you have a fraction and you want it to be equal to 1, the numerator and the denominator must be the same. If they are, then we can say that the fraction is 1. So it doesn't look like they are, but actually they're the same. Okay? Remember again that 1 over the square root of x squared, what's the square root of x squared? It is x. Supposing, of course, that x is a positive number. So remember that x is a positive number because x approaches positive infinity. So 1 over the square root of x squared is 1 over x. Divide that by 1 over x, you still get equal to 1. All right? So the factor is still equal to 1. Yay. Okay. So we always want the factor to be equal to 1 to ensure that we are still looking at the same function. The old function does not change because we just multiplied it with 1. But what is the effect of this? So to continue our solution, this will now become the limit of the square root of, okay, x over x squared plus 3x squared all over x squared divided by 4x over x minus 1 over x as x approaches infinity. All right? And further simplifying, we get the limit of, you have the square root of 1 over x plus 3 divided by 4 minus 1 over x as x approaches infinity. And then using the preliminaries that we have, we know that this is just the limit of the square root 1 over x plus 3, where this is 0. And we have 4 minus 1 over x as x approaches infinity. And again, we know that 1 over x is just 0. So finally, we have just the square root of 3 over 4. And there you have it. Okay, so the lesson in this particular example is that not only do you multiply it with 1, but you have to take into consideration that there is a radical. So in this case, you look for an equivalent expression, okay, but this time incorporating a radical. Sir, medyo malabo. Don't worry, we have another example for you. Note, however, okay, I want you to note that this particular example now makes use of negative infinity. So we are looking at values of x that are negatively large, okay? What is the effect of that? It is because when we take now the limit, the multiplier, okay, 1 plus 4x to the 6th divided by 2 minus x cubed as x approaches negative infinity. Okay. Sir, we asked, typically we ask what is the largest exponent with respect to x? In this case, x cubed. Bakit sir x cubed? May nakikita kong x to the 6th? Well, because the square root of x to the 6th is x cubed. So pala sir, I should be using 1 over, gaya kanina, square root of x to the 6th divided by 1 over x cubed. Tama? Mali. Is this, so to answer that question, tama, mali, you're just being asked basically, is this equal to 1? 1 ba ito? The problem is, hindi. This is not equal to 1. Sir, bakit? Okay, this is how it is explained. Remember, you have a negative large number. So you take out large number, still it is a negative number. When you get, or rather, when you raise that negative number to the 6th power, because 6 is even, mawawala yung pagiging negative niya. Okay? Imagine negative 1,000. Remember, when you square negative 1,000, it becomes 1,000 squared. Just like negative 2, when you square, magiging 2 squared. Nawawala yung pagiging negative because the power is even. So when you have a negative large number but raised to the sixth power, it becomes positive. And so when you take the square root of a positive number, you get a positive x cubed. Now, compare that to the denominator. You have a very large negative number and you cube it. Because cubing does not make your um, uh, number positive. Okay? When you have, for example, negative 2 cubed is negative 8. It's not 8. Okay? So the same thing, when you have a negative large number cubed, you get a negative number. So this is not equal to 1. In fact, this is negative 1. So sir, how do you make this equal to 1? Okay? We're just going to take the negative of this. Okay? Why? Because this x cubed is a negative number times negative, magiging positive na, which is the same number as the numerator. And in which case, yay, equal na siya ulit kay 1. Okay? Magiging equal na siya ulit with 1. Okay, so having done that adjustment, remember we made an adjustment. Let's continue. Okay, so the limit of, we have now the square root of 1 over x to the sixth plus 4 x to the sixth divided by x to the sixth. Divided by, okay, and then you distribute negative 1 over x cubed, so you will have negative 2 over x cubed plus x cubed over x cubed as x approaches negative infinity. Sir, this can further simplify into the limit of square root 1 over x to the sixth plus 4 divided by negative 2 x cubed plus 1 as x approaches negative infinity. Which, using our preliminaries, sir, this is practically 0. Sir, this is practically 0. So you get just the square root of 4, which is 2. And there you have it. Remember that in this particular problem, we are using the same procedure, except that we made an adjustment where appropriate. Okay, because you always have to remember that the factor you multiply must be positive 1, not negative 1. All right, so now we reach the last problem in our board work for today. So we have this radical expression, square root of 4x squared plus 3x plus 2x as x approaches negative infinity. And what is the limit of that? All right, so it's difficult because we don't have a fraction, correct? So what we're going to do is we're going to make a fraction out of this by multiplying the binomial conjugate of this expression. So let's just first rewrite that. Okay, we want to take the limit of 4x squared plus 3x plus 2x. Okay, and then, like I said, we multiply this with its binomial conjugate. Square root of 4x squared plus 3x minus 2x divided by, okay, so for the sake of, yeah, okay, so that it's readable, all right. divided by okay, divided by square root of 4x squared plus 3x minus 2. Again, you will notice that this is just equal to 1, so there's no problem there. We have actually preserved the old function. Okay, but this will result into something that we can analyze clearly. So that the numerator will now become 4x squared plus 3x minus 4x squared, okay, divided by square root of 4x squared plus 3x minus 2 as x approaches negative infinity. This will give you, 2x minus 2x. Right, so this will simplify into the limit of 3x divided by square root of 4x squared plus 3x minus 2x as x approaches negative infinity. Right. And now we remember, we can ask again, so what is the largest exponent with respect to x? It will appear that the largest exponent with respect to x is x. But because we have a radical, okay, we can make an appropriate adjustment for that. Okay, so how do we do that? Okay, first we rewrite 3x divided by the square root of 4x squared plus 3x minus 2x times, as x approaches negative infinity, you have 1 all over x divided by 1 all over square root x squared. But, okay, again, realize that this 2, is this equal to 1? Before we can do this, we always have to check, is this equal to 1? Remember that we are evaluating values of x that are negatively large. Negatively large. So let's analyze. Sir, if I have a negatively large number and I square that, I will get a positive large number. Correct. You're going to get a positively large number. And the square root of a positively large number is a positive number. Correct. How about this? Well, this will remain negative. So, sir, I have negative over positive. It's not 1. It may be negative 1. So, what do? We make the appropriate adjustment. Sir, this must be negative 1 over x. When we make that negative 1 over x, then it's very easy to say now that indeed it is 1. All right. So this will become now, this will become now the limit of negative 3x over x divided by the square root of 4x squared all over x squared plus 3x over x squared. Okay. Now, here, because this negative 2x is not in a radical, we have to use this form negative 1 over x. So this will become plus 2x over x. Okay? So as x approaches negative infinity. So this will give me the limit of negative 3 divided by the square root of 4 plus 3 over x plus 2 as x approaches negative infinity. So now this will just be using the preliminaries that we learned earlier. This is just equal to 0. And so we have negative 3 divided by square root of 4, 2 plus 2. Or this is negative 3 quarters. And there you have it. Right. So I hope you learned something from that lesson. Thank you very much and see you next time.